Fantastic. I'd like to start today by thanking Project for assembling this great event. I'd also like to thank my fellow speakers who have been on some of the previous sessions and sharing their time, knowledge and experience. But most importantly, thank you to everyone for taking the time to participate in this session and being part of the Maximo community. It's great to be here with you today. So today I'm going to explore with you some answers to the following questions. BIM's had an incredible success in design and construction, and I want to look at why this is the case. And then can these same successes be transferred to operations and maintenance? What are the opportunities on the table for us? And finally, if your organisation is wanting to take that first step with BIM, what should your organisation do to start moving down the road to digital twin? Firstly, about COSOL. COSOL is a global provider of asset management solutions with offices in the United States and Australia. We are an IBM Gold partner with over 400 professionals working across the globe. We take a collaborative approach to problem solving, applying our industry, technical and functional expertise, combined with best of breed technologies to help our clients achieve asset and operational efficiency. I'm David Lestani and my role at COSOL is Principal Solution Architect within the IBM practice. I have qualifications in information management, surveying and GIS. In the 20 plus years working in asset management, my career has loosely followed the asset lifecycle. So early on in my career, I worked in both the sort of natural and built environments. I then transitioned from creating spatial representation of as-built assets to using my information management skills to help organizations better manage these assets. I now facilitate the establishment of continuous improvement programs across what COSOL has defined as the asset ecosystem. As many of you would know, implementing Maximo is not done in isolation. And to get the most from your investment, Maximo must be integrated in some form or another with different systems to establish the asset ecosystem. Some examples of these integrations include finance, HR, document management, GIS, and of course, our topic today, BIM, or Building Information Models. COSOL is grateful to have a strong partnership with a leading digital engineering organisation, DVM Vercon. Throughout the presentation today, I'll be sharing some of the work that we have done together for our clients. So firstly, I wanted to start by looking at BIM's success. Building information modelling is a digital representation of physical and functional characteristics of built assets, from bridges and buildings to production plants and processing facilities. And more so today, even in some moving assets such as trains, trucks, buses, etc. It helps design and construction teams aggregate information and work more efficiently on the creation of new assets and infrastructure. The importance of BIM is widely recognised to the point where it is now mandated for many countries for very large projects. From this mandate has come ISO 19650, which is the international standard for information flow. For the scope of today's discussion, we're focusing on the transition from the project information model to the asset information model as part of the information deliverables. Let's take a look at the benefits of BIM from architecture, design and construction. So looking at BIM over the entire asset life cycle, there are handover touch points where major risks occur in terms of information loss and product not being continued onto the next phase. So the return of investment is incremental when you think of the timeline for how long it takes to design and build an asset versus its overall operating lifespan. But if we take a focus on the specifics of the architecture and design phase, it's very much around the collaboration. So working within design teams, especially when they're sharing data using the ISO 19650 standard, but also external stakeholders as a tool for communication. Constructability, so can we actually build what we've designed? Does this design concept satisfy the law of physics? And then finally, around the cost estimation, doing the takeoffs, understanding the costs to build the current design. Then when we look at the construction phase, we put a lens on that. Again, you'll see that collaboration is a key benefit, where sequencing of work packages, coordinating multiple trades on site with construction exclusion zones, sequencing the delivery of materials, the actual physical construction, movement of cranes, etc. So BIM provides that visibility and collaboration. From a project management perspective, working on cost control, providing progress reporting to stakeholders, and also milestone billing. Quality control, as we're using the model, we can minimize those construction defects that may occur if it was not as coordinated construction. And then finally, with the commissioning, all of that as-built data capture, asset serial numbers, manuals, etc., can all be packaged into the model as part of that construction finalization of the construction phase. In summary, the benefits are derived from the information products that are actually packaged using BIM as the delivery medium. These information products enhance our ability as humans to consume very complex assets through a spatial representation. So we're getting context. However, it is no longer just about the geometry. It's the geometry that has been enriched with attributes that extend into 4D with temporal inputs and into 5D when we include cost. The asset owner, either knowingly or in some cases unknowingly, is contributing a significant investment in developing this digital asset. What COSOL is seeing is that very few organizations continue with this investment beyond the completion of construction. So now we're going to explore some of the reasons why this is the case. So what are the BIM blockers? So COSOL has seen that large projects involving the delivery of BIM digital assets are usually burdened with the following constraints. Contract scope. So requirements for BIM are drawn up with the needs of design and construction outcomes, not operations and maintenance. In fact, what typically occurs in very large projects is that the constructor and the maintainer are entirely different entities. What COSOL sees is that the O&M contractor is not even engaged at the design and only partially way through the construction. So their requirements to implement BIM are not considered in the early phases of establishing that initial contract. So this means that if an O&M contractor would like their requirements, that will imply a variation to the master construction contract to improve those final deliverables. But rarely are these needs met as they are not in scope. Understanding of the O&M use cases is another problem that we see, and organizations reach out to COSOL and ask us, we've just finished the project, we've been gifted this BIM artifact, can you load it into Maximo for us? If only it was that easy. The reality is that the data and structures required for operation maintenance mean that significant rework of the models is required. And from the previous point, that usually doesn't happen from the constructor. Thirdly, the quality of models. A BIM deliverable issued at the end of construction is not suitable for operations and maintenance use cases. These models include attributes with ancillary information that must be removed as they add no value. Geometries may need to be split or dissolved to align with the O&M assets. And lastly, available expertise. BIM practitioners are plentiful during architecture, design, and construction. However, they are not prevalent in operations and maintenance due to the more static nature of the models. Finding a partner that can provide this expertise on a retainer is the way to go to solve that particular problem. So in the perfect world, COSOL is seeing that more opportunities for asset maintainer organisations having influence on those early contract specifications. We're observing a reluctance from organisations to add scope as the margins are very tight. However, the positives are that dialogue is occurring. The first few large projects will be difficult until this approach is normalised and becomes industry best practice. What I am hopeful for is that the design and construction teams involved in producing these incredible BIM artefacts will recognise that their work has scope to continue for the life of the asset. I hope these new opportunities to extract even more value from this digital asset will be accommodated, for which the contributions of these digital engineering teams will be recognised. Essentially, it's going to be their legacy. So from an operations perspective, what are the opportunities? So we understand now the benefits of BIM through the lens of design and construction. We understand what the typical blockers are that prevent a clean handover to operations and maintenance. Now we're going to expose and explore some of those key opportunities for BIM. We're going to look at my top 4 reasons how BIM can benefit operations and maintenance. So the first opportunity is automating the creation of the asset register. We're essentially automating the creation of location hierarchies, location systems, and assets from the federated BIM model. I can guarantee that many of you on the call today have been given spreadsheets and asked by your boss to populate the asset register in Maximo. These spreadsheets typically have bloated number of tabs, complex lookups, and not to mention multiple versions are issued. Hopefully for you, not by email. If you are lucky, you might have even been given a companion set of drawings which you use as a reference. Perhaps you've tried using COBie as the data exchange format. COSOL's experience with COBie is that you get one shot at the upload, with the naming conventions typically not aligning with how your organisation's naming conventions or standards. COSOL has implemented 2 BIM integration approaches. The first is where the asset and location custodianship remains within BIM, with the asset information updated in BIM and synchronized to Maximo. We see this in some situations where it's contractually mandated that the BIM artifacts must be maintained to represent the current state. The second and my preferred option is the location custodianship for spaces managed in BIM and the asset custodianship handed over to Maximo. References to assets are removed from BIM and dynamically linked via the location identifier. The benefits of automating the asset register creation is that filtering can occur using modern integration tools. When COSOL implements this approach, we use web services to bring information into Maximo. The web services hosted with the model detect changes and publish them for the consumption by Maximo. Projects that do span multiple years, I typically see us bringing in the locations first with no asset details. This allows for the operations and maintenance teams to build out their maintenance strategies ahead of commissioning. And then on commissioning, those details and defects can be reported and captured against the location whilst waiting for the as-built asset details to arrive. In terms of terminology, just wanted to point out that there are some subtle differences between BIM and Maximo that you need to be aware of. The good thing is that the mapping is achievable, and COSOL with DVM Vercon have developed processes and tools to simplify this data exchange. When we're looking at it from the attributes, again, there is mapping required to filter out any of those sort of attribute data points that are of no value in operations and maintenance. My second opportunity is improving maintenance planning. Visually understanding and coordinating maintenance works into work packages. So selecting work orders from the model, then organizing them into a work order hierarchy. Looking at work reported and analyzing historic work to identify trends and learn from known effective corrective actions. identify site access and tool requirements, perform measurements and takeoffs within the model to check if the specialized equipment will fit into the space. Testing procedures in a digital environment and reducing time attending site. Is an elevated work platform required to access this jet fan? I'll finish off our presentation. I'll give a statement on savings realised for an oil and gas customer, just around how much benefit doing things remotely has benefited them. I'll just share with you now a quick video of BIM in Maximo, and we're going to explore an oil and gas customer that has a mobile skid. We can see that attribute information has come from the model, and then when we look at the 3D view, we can get context to the asset from within Maximo. We can navigate to other assets, inspect nearby assets, in this case looking at a valve, and we can get that context within the entire facility or area that you're working within. We have all of our attributes available to us. We can also link off to drawing management artifacts. All right, I'll jump onto another quick presentation. And this is another example of civil infrastructure. So looking at the, seems to be repeating. Okay, so the third reason for BIM in operations and maintenance. So we're looking to inform repair or replace decisions. So with BIM, we can overlay work orders thematically by type, and whether they're reactive, planned, is this a condition monitoring or an opportunistic work order. We can look at color coding on priority, frequency, onto the model. We can display condition data or health scores on the model thematically, bring together Maximo's new reliability-centered maintenance capabilities to focus engineers on reviewing outlier assets. Using simple traffic light color coding approach to identify the location of repeated reactive work orders can quickly and easily identify whether further investigation into the cause of asset failures is warranted. We can use sliders to view work order history backwards and forwards in time to help engineers target their analysis on specific time windows. Within Maximo Civil, we're also seeing capabilities to use red line markup within the model to track and manage defects. The fourth reason is for visualizing that asset performance. So the ultimate value from our investment in BIM is achieved when we combine BIM with the entire Maximo application suite. So Maximo Manage provides us with the current as-is state of our assets and historic performance through work order history. We can also look at future preventive maintenance work orders, and corrective backlog can be visualized on the model to get an indication of work hotspots. Maximo Monitor brings sensor data and machine learning graphically into the model. Using time sliders, we can observe historic performance on the model. We can also highlight assets that have anomalies or are trending towards a failure. Maximo Health brings an overall picture of our assets to aid reliability engineers to focus their investigation on outlier assets. We can use the model to determine what other contributors could be causing specific assets to not perform by understanding the context in which those assets are operating. Maximo Predict, we can take the recommendations from Predict and present these as highlights on the model for reliability engineers to bring context to their analysis. Essentially what we're talking about is taking a step closer towards achieving digital twin. The next quick demonstration is a civil infrastructure where we're looking at a segment of road, a segment of tunnel with has a substation attached to it. So you can see how easily it is to explore within Maximo the assets. You can plan work, you can visualize condition of assets, and we can look up both tunnels without the fear of traffic and other access issues, looking behind panels and walls. In this particular one, we can also see the fire suppression system that has a number of valves and equipment in the cross passage. Just going to jump to another example, and this one is showing condition overlaid onto the actual model itself. So we're using our color coding and specifying which attribute. Again, we've got condition data that's captured from surface testing, and we've put some sample colors onto the lanes to show the skid resistance. So you can quickly visualize on the asset itself the condition rather than looking at a PDF report of results. So we're bringing in the condition data and overlaying the current conditions real time onto the model. So looking at these opportunities from a user's perspective, from a maintenance planner, it's really about that visualizing and seeing and interrogating work orders by location. Having the ability to pick a future PM, existing work orders, and create that work package. From a reliability engineer's perspective, it's really about, again, visualizing patterns, trying to use that as an aid to identify the root cause. From a maintenance engineer, it's about testing alternative work methods before going on to site. So really focusing on first time fix. So implementing BIM and the road to digital twin. So what are the foundations needed for your organization to implement BIM? So firstly, a recommendation is that you adopt a digital engineering approach to managing your BIM artifacts. If you do not have those digital engineering expertise, then partner with a specialist provider to support you with the model management and curation. Adopt ISO 19650. This is the standard for working with BIM artifacts across the asset lifecycle. Standardize BIM requirements in contracts. This is a critical step needed before any new project is contracted, that you must have those standards and practices as part of the contract specifications. So when you receive those BIM deliverables, you are receiving what you have asked for. Establishing a BIM management plan, so your processes internally for how you're going to manage those BIM artifacts, and the final one there is ownership of the data. Establishing that common data environment, understanding what BIM is responsible for authoring and being the system of record for, and what your asset management system, Maximo, is the system of record for, and how those two systems share data with each other. And finally, the steps to adopt. If you have existing assets, but you do not have BIM, you can undertake a laser scanning and back modeling to develop BIM artifacts. You can also implement that back modeling by taking existing 2D plans, if they are current, and creating those BIM artifacts. The next one is you've got existing assets, you have BIM, but they're not integrated. What you need to do in this situation is review that asset information model for consistency with Maximo, You need to then go and condition those models for those O&M use cases. So it's organizing the hierarchies to align with Maximo, removing unnecessary attributes, splitting or dissolving geometries to match those Maximo functional locations and or assets. And then finally, if it is a new construction, make sure that those BIM standards are part of the contract specifications, and you will see that those O&M use cases will be enabled. So I just wanted to close out before the Q&A just with a quote from one of our clients. So an oil and gas customer that implemented BIM across their geographically dispersed unmanned sites realised a cost saving of over $500 million over a 4-year period. Staff didn't have confidence in the as-built drawings as they were not maintained and would have to drive or fly hours to inspect and then prepare corrective plans. By not having staff attend site, reduced the cost of implementing health and safety risk mitigation practices, and staff were now more confident to use the models and effectively plan their work remotely without attending site. I'll just take a pause there and check for any questions. As a question on configuring the BIM viewer in Maximo, what does it require? So the BIM viewer in Maximo, there's a IBM configuration for the standard BIM viewer. So there's essentially notes on how to install and deploy the BIM viewer. It's using the Autodesk Forge viewer. There's another question around which industries are leading BIM adoption. Okay, from my sort of personal experience, definitely oil and gas and infrastructure, I'd say they're probably the leaders. Somewhat water utilities, I think they're sort of in the early stages. My sort of take is that, yeah, typically industries that are using GIS, and they're the sort of projects that I'm involved with. Another question on the tool to import data into Maximo from BIM. So COSOL and DBM Vercon, we've actually developed some proprietary tools and integration methods. So we've automated a lot of that, those sort of manual steps. So that process is yeah, essentially automated for us. Last question. What BIM viewer did you show? Is that the standard viewer? It's actually an enhanced version, what I shared, of the Forge viewer. We've actually built that with DBM Vercon. It's got a few additional sort of functionality for some of the overlaying of the condition data into the models. Okay, it looks like one other question. How is this connected to IoT and AI? So the IoT and condition would be coming from monitor, and the way that we've configured the models is that any data can be surfaced within the model. AI would be not done by the model, but externally, and the results overlaid onto the model. All right, looks like we are up for time. Thank you everyone for joining and making time to be with me today. And thanks, Joe and team.
Yep, thanks, David. Good stuff. See everybody in the next session.